So as we go ahead and take a look at quadratic graphs and their properties, notes 9-1, day 2, okay, we're going to look at, can we graph a quadratic function in the form of y equals ax squared plus c? So we're adding that plus c. Let's go ahead and do a quick little review here. Okay, for my review, before the first part of our notes was talking about, we just had the ax squared. We know in those situations our vertex is always 0, 0. Every single time. We graph and we make a table. So now when we're adding this plus c, take a look at how your vertex turns out. Your vertex is going to be 0 for the x value, and whatever that c is going to be that y value. Now I want to remind you that the formula says plus c. So let's take a look at example 1. Y equals x squared minus 3. I want us to take a look at that. I don't like the minus 3 because that's not what our formula says. Our formula says y equals ax squared plus c. So let's change this. We need to rewrite it. We're going to rewrite it as y equals x squared plus a negative 3. So when we're looking at our vertex, we have to be able to identify our c here. And our c is that negative 3. So our vertex is 0, comma, I'm just going to write over that part right there, negative 3. 0, negative 3. You'll notice that I did put it right in the middle of my table. And we're going to go ahead and plug in one value less than that 0, which is negative 1. Let's see what happens if I do that. So if I plug in a y equals, in parentheses, negative 1 squared plus negative 3. Negative 1 times negative 1 is positive 1, plus a negative 3 would be a negative 2. Now, did we learn from yesterday that whatever we put in that's 1 away, if we're 1 the other direction, it's going to be the same answer. If I put a positive 1, if I change that to a positive 1, we're still going to be at negative 2. Now let's go ahead and check if we substitute in a negative 2 for x, we know that negative 2 times negative 2 is going to be a positive 4 plus a negative 3, which would be a positive 1. And we know if we plug in a negative 2 for x, and we plug in a positive 2 because they're both 2 away from that vertex, they will be the same answers. Remember to evaluate using your order of operations. We do have to square our numbers before we can add or subtract. So as we go ahead and plot these points on our graph, I'm going to go over 0 and down negative 3. 1, 2, 3. That would be our vertex. And now we're going to go over to negative 1, down 2, over positive 1, down 2, over negative 2, up 1, over positive 2, up 1, and we can see our u here, our parabola. We also could identify that the y-axis here is actually our axis of symmetry. Axis of symmetry, okay, would be the y-axis. We can identify that our a, if we look back to our original equation, our a is positive 1. It's not written, so we know it's positive 1, which means we do have our graph relates to that. Let's go ahead and look at a second example. So we're just going from having just our ax squared to now having an ax squared plus c. No b, just the plus c. Is going to be, when we have the form y equals ax squared plus c, our vertex will be 0, comma c. That's it. Have a good one. So looking here at this example, let's talk about that vertex first. We have to identify that this is in the form of y equals ax squared plus c. If it's not in that form, we got to use a different method. So since it is, we know 0 will be our x value, and that 4 is going to be, it's a positive 4, is going to be my y value. Okay, let's go ahead and go 1 away from 0, which would be -1, and if I go 1 the other direction, it's going to be +1. And so if we plug that in, I would have y equals -1/2, parentheses, -1 squared plus 4. -1 squared is -1 times -1, which is a +1. -1/2 times 1 is just -1/2. Excuse me, and if you add 4, you're at -3.5. -3.5. Remember, because we put in that -1, and that is 1 space away from 0, +1 is also 1 space away from 0. It's going to be symmetrical, so it will be the same answer. Let's go ahead and put in a -2 and a +2. So if I go ahead and put in, I have my -1/2 times -2 squared plus 4. -2 times -2 is +4. We're going to have to bring everything else down and multiply it by the -1/2. So -1/2 times 4, well, half of 4 is 2, so it's going to be a -2 plus 4. -2 plus 4 is just going to be a, I'm sorry, time out, go back. This should be a +3.5. I don't know why I put negative. I apologize. This right here should equal a +3.5. Okay, so -2 plus 4 is going to be a +2. We're going to go ahead and put that in, those values in. As we go ahead and go to graph this, let's start with our vertex. It's at 0, +4, 1, 2, 3, 4. Our vertex is in blue. I'm going to go to -1 and 3.5. I'm just kind of estimating it should be right halfway between. And then I'm going to go to -2 and +2 and +2 and +2. And as we go ahead and graph that, what we can see is we have a -a. So it's going down. We have a maximum value. We have an axis of symmetry on the y-axis. And it's very similar to what we were looking at yesterday. We just added the c.